Serigar. I am a mechanical engineer from Mott MacDonald Private Limited, and today I am going to present a paper on the topic AI-Augmented Water Infrastructure, a system thinking blueprint for India's net zero 2070 vision. So India has set a very ambitious target of net zero emission by 2070, and this has been said by none other than our Honorable Prime Minister Shri Narendra Modi, where during the recent COP26 session, our Prime Minister has submitted a five-fold plan, also known as the Panchamrit plan of the climate action for India, in which it basically talks about the various carbon opportunities which the Prime Minister wanted to what has promised to at the COP26 session, such as to reduce the projected carbon emissions, to cut down the intensity of the economy by 40% by 2030, to achieve the net zero emissions by 2070, to generate 500 gigawatt from non-fossil fuel energy, and to fulfill the 50% of the energy requirement of the energy grid requirement from renewable sources. So, looking at the water infrastructure part, we have two major dual challenges here. First, to provide an equitable, accessible water to all Indians, and second, decarbonizing one of the world's most resource intensive infrastructure component. So water system as an infrastructure, it spans across three: to take, to supply, to treatment of it, and when it comes back from sewage treatment, to treatment of that. So it gets spanned across the three parts of it, and which are all energy intensive and climate vulnerable, constrained by the aging assets, high emission intensity, and fragment governance. Climate vulnerable from the difference when the wastewater gets discharged to various sea water or river water, it gets vulnerable. So this poster presents a systematic system thinking blueprint that helps to embed AI across the water asset life cycle by leveraging digital twins, generative design, and predictive analysis, while calling for a climate aligned procurement, updated design standard, and codified the sustainability in the infrastructure codes to help us enable an intelligent responsive system which can help to achieve our India's net 2070 vision. So before we go, let's see what are the challenges India currently faces and how it can be seen as a hindrance to our net 70 goal. First and the foremost is the energy intensity. Currently, the coal, if you look at the statistics of the power generation website for 2024, more than 70% of the power generated by thermal and coal sources. So that is again one of the major block, if you can see towards our goal of net 70. And then secondly, fragmented governance. Water in India is a very particularly state focused, policy driven. Every state will have their own policies, and every will have their own way of working the things out. So there is no unified governance where how to treat and there is a particular governance and how a water infrastructure needs to be designed. Coming to the main important infrastructure losses, we have a high infrastructure losses in cases of water supply. Like let's say the NRW, the non-revenue water, in rural India is around 40 to 50%, and in cities such as Bangalore and Pune it is around 35%, which is very high as compared to the global standard of 10 to 15%. So this is some of the losses. So when we say there is 35% of losses happening, it's not just the precious loss of water, but the amount of energy which is being spent to treat and supply them, that also gets lost. Again, then the financial constraints, we have focusing on much currently being focused not on the AI augmentation or less carbon intensity, but being focused on currently just supply and get the water infrastructure done. Like the Jal Jeevan Mission, we focus on getting the rural tap water to every household, but then it's only restricted to water quality measurement. But do we have monitor it? Do we have real-time monitoring of all the taps? That is not currently being a constraint of that. And then there is a risk aversion which we have. We have a very low adoption or reluctance towards inculcating latest developments of AI computing. There are projects in Tiruvananthapuram and Pune where They have started a pilot project on implementing AI monitoring, but then it stayed as a pilot, it never went as a full-fledged. And then digital divide. You might have known about the smart cities project. That is, we have a lot of smart cities project planned and proposed. But in reality, if you see in 2024, only 17% of the smart cities have been successfully completed, and rest of them have just been on the paper. And when you say smart city, because with smart cities there is a smart infrastructure, water infrastructure being water infrastructure which is aligned with that, and that helps to in a way to control the integrated control system of the water. So we know the challenges. We know what is the challenges right now. Where is India standing, and what we need to achieve. So this is where we are trying to now let us see how we are going to achieve those. So we have a very good guiding principle by Ernst & and FedEx, which they have said is 5 guiding principles to achieve the net zero emissions of 2070. So if you could just quickly go through those, so this is the well-defined framework developed by EY and FedEx to embedded AI into an infrastructure project. Looking into the water infrastructure segment, we have the 5 steps, which is first to determine the purpose. By using the AI, we can help to determine what exactly the purpose is, and we can help to have the major feasibility study done, which helps to reduce the we can optimize the power generation, or use the less carbon intensive material at the very start itself. Second, coming to planning to end to end, right from the construction feasibility stage to the operation and maintenance stage, we can plan all the end to end of the system, which can help you to reduce the risk associated with the energy intensity, and also help using the AI we can do the risk modeling, which can help to again reduce the carbon and the net zero emission by 20%. Confirming the operating model, once we have confirmed the plan to end, we can use digital twin model to confirm whether the particular model which we have selected for infrastructure will work accordingly or not. And then integrate the ways of working using the AI APMOs. We can use it to integrate and analyze to reduce and optimize the workflow. And finally, operate the responsive assets. So since at the end of the day, it is how you operate the asset is like. So using AI, when you deploy AI and IoT, it can help you to cut the downtime by 30% and reduce the O&M cost by 15%. So quickly going through where can the AI can help us to have the opportunities across the life cycle. Starting with the planning and design. So this is where you can start with the AI planning and design. There are various software such as Bentley ProjectWise, which can help you to do so, which can help you to start, plan and properly. Then second, construction and monitoring. There are various platforms which can be used to help you to select a much efficient process, which can be less power intensive, more efficient, or take some carbon intensive materials which are very less carbon intensive materials, which can help to reduce the carbon footprint. And then third, the operation and maintenance. This is where the digital twin come into place. Like instead of we can have the operation and maintenance, we can have a digital twin working with us, which can give you the best operating working model, and based on that can help us to get the best required output of that. And when you're talking about digital twin, from one of a place, if we club the data from all of the multiple places, from that we have a huge amount of data, which when integrated on a large multiple scale on a national level, we have a very great database of the very efficient model, which can help us to get the best output from the intended purpose and also achieve our goals. So if you just quickly look at the AI impact level, as I mentioned, it starts with planning very less, but then if you go to the design, we have some scope. But if you go for construction, operation and maintenance, this is where AI can help you drastically to increase the energy efficiency and reducing the net zero emission. Again, coming to the main point right now is the India CPHO manual. So water infrastructure is basically designed India is basically designed by various codes and standards, but we as a water company will normally look for the India CPHO water and sewage manual. But if you look at the CPHO manual for water and sewage manual, there is less than one references for net zero or carbon. In the sewage manual, there is 0 references for any of there is push for you to go for an efficient pump selection or efficient mechanical equipment or efficient any energy intensive material. But the latest model of CPHO motor does include one para of using the AI to help you to reduce the energy intensity, but it is mostly related to GIS. So coming to the roadmap which we have developed is right now is like how we can have a phased strategy to embed AI across the life cycle while addressing all the current policy and the standard gaps which we have. So if you show, we have divided into three parts: mid-term goal, short-term goal, mid-term goal, long-term goal. So first and the foremost, we can start by launching the pilot AI projects, the Smart Cities 2.0, Amrut 2.0, and then we can start having an AI readiness index for the utilities. And first and the foremost, when you don't know what is it, how can you start using it? So that is first the training comes into the picture. Then we need to start identifying where is the gap exactly is and how we can plug those gaps. So reviewing of the key design manuals which the infrastructure companies use, the CPHO and another key design manual, and need for AI and the carbon integration in the national codes. And then the third phase is the build phase, to integrate AI into the existing Jal Jeevan mission which we have, and also to mandate digital twin in the tenders. So now currently if you look at the tenders of any of the water projects, there is no mention of any of the promoting use of AI or any of the efficient processors. So you in the tender stage itself you can start mandating the infrastructure companies to implement digital team, not in the design stage but at least in the operation and maintenance phase, which can help you to start the journey at least. And then going to the next to update the standards after identifying the gap, to have a draft AI carbon metrics for the water infrastructure. And then going to long term is like to codify low carbon solutions into the standards. If there are certain materials such as ductile iron which consumes more carbon than the other normal conventional pipe materials, you stop proposing that material. You go for an, even if it comes for a higher capital cost, but if there is a less carbon intensive material, let's propose that. Let's codify that inside the standard itself, so that water infrastructure companies will definitely have to use those things. This is just an example. Then scale predictive maintenance across major utilities. So since we started with mandating digital twin, when we can start mandating and scaling up the digital twin across the utility. And then again the vision 2040 plus, this again is a vision, but this is like we can have currently we have various dashboards for across the India. Like now we can have a same for AI powered national water resilience dashboard and institutionalizing AI based planning and urban sanitization. So this is the particular roadmap. Just before I conclude, there are various stakeholders informed. Since this is not someone's only one person's responsibility. It's a group thing which everyone has to be equal stakeholders. So there are various stakeholders currently right here, and those needs to have their key responsibility. First, government. The government needs to have update on the policy, the funding. They need to be open on the data initiatives. Second, the asset owners. The asset owners they have to start mandating the AI use, invest in digital infra, in monitor outcomes. Then third comes the consultant, like people like us, consultant contractors. When we are designing it, we have to start implementing AI tools. We have to ensure data quality and upskill. The fourth is the technological providers. We have various technology providers. They should start scaling the AI integration. And finally, academy and institutions. This is where it should start building up. They should drive research and clear education and have certificate program. To conclude, we have India's water infrastructure is not just a technological announcement; it's a social imperative. By looking at the by looking at current situation, what are the gaps and what is our aim, we can have by following the best practices, we can ground it in the global best practices, tailored to India's unique need and designed to be actionable and scalable, with the right amount of the policy support from each of the stakeholders mentioned and the investment. But obviously investment is one of the main thing. AI can surely become a cornerstone in our India's net zero journey and be a leapfrog to help us achieve the same. And these are ending with this. This is some of the global case studies. As I mentioned, we have a risk aversion. You know, people tend to not they fear to invest this. But we have local and global case studies which has proved it otherwise. So that can be helped. So yeah. And if you want more information, you do scan the QR code for references. Thank you.